Hey there, I'm Joe Weems. Before we get into the video, I want to remind you about ng-conf 2023 happening in Salt Lake City, Utah on June 14th and 15th. Head over to ng-conf.org to check out the speakers, check out the talks, and to get your ticket before they all sell out. We'll see you there.
We're going to talk about RxJS best practices and that they aren't always just black and white. I got the link to the slides and the code on here, and I also have it on the last slide in case you miss it. All right, my name's Deborah Kurata. I'm a software developer and a Pluralsight author, and there I am, wherever I am over here, in one of my favorite places on the planet. I hope to go back someday if you ever have the chance. It's just really fun. Okay, so my first best practice when working with RxJS is to be declarative. So what do we mean by that? When we learn RxJS, we frequently learn to do it in a procedural way, where we're going to write a procedure, a subroutine, a function, whatever you would want to call it functions in Angular. We write some kind of function that's going to get our data, get users, get customers, whatever our get is, and that's where we have our HTTP GET to request the data from a server somewhere. Using a declarative approach, we instead declare a variable like users $, and assign that to our HTTP GET. So it's a very small change if you just look at the two different versions on the slide here. But by going declarative, you have a lot of benefits. You can more easily merge or compose streams together because you have them all in these individual variables that you can put together and filter and merge. You can easily communicate between components because one component can emit something into the stream, and all of the components that subscribe can react to that. You can manage application state, and there have been quite a few speakers who have talked to that over the course of this conference. You can also react to user actions, and we're going to talk about that one a bit more. But as soon as I start talking about declarative as opposed to procedural, I have someone that comes up to me and says, wait, Deborah, I have parameters on my HTTP call. I have to have a procedure, because if I don't have a procedure, a function, I'm not going to be able to pass in the parameters that I need for my HTTP GET request. So never mind. Okay, I guess we're done. I'm going home. No. So how do we deal with this? The idea here is, instead of thinking about it as something that you have to pass into a function call, instead, think about it as something that you're going to react to. I should probably make that a mantra too, right? Since that's been so popular. That we're going to react to something. How does that work? Well, we're going to go reactive. Do we want to try that? All right. So I'm going to say go. You're going to say reactive. Right? It's been working, right? Okay. Go. Reactive. Go. Reactive. Perfect. All right. So how do we do that? Well, here's our little scenario. I've got a drop-down list of users. I am a software developer. I have some juniors working for me. I have a list of my junior developers, and I want to look at their tasks, see how they're doing on them, who I need to maybe help. So that's our scenario here. So we want to react to the user's actions. That takes 3 steps. The first step is to declare an action stream. Second step is to emit a notification when the action occurs. And third step is to then react to that notification and do something. So we're going to take these one step at a time. First, we're going to declare an action stream. And as you might guess, the way that we do that is with a subject or a behavior subject. We define the subject or behavior subject as private so that it's encapsulated in the service that declares it. Why do we do that? because we don't want any other part of our application to be able to error it out or complete it or put anything into it. We want to control where it's being emitted into. However, we do want the whole rest of the application to be able to subscribe to it, to access the read-only parts of it. So that's what that second line is for. We declare our observable that is kind of the read-only part of our information, which is that emitted value. Our second step is to emit a notification. We do that here in our little method. We do that when the action occurs, and that calls the behavior subject or subject's next method. And the third step is to react to the notification, and that's where we're going to perform our action. In this case, we're going to take our user-selected action, so which user I selected, and we're going to pipe it through a SwitchMap, and that's when we get that user ID, and then we have it for our parameter on our HTTP GET. Make sense? Yes, roared the crowd. Thank you. So we can use, for our action, we could get related data, we could save on a save action or whatever else that we would want to do here. So how did I know to put a SwitchMap here? Is it best practice that I should always use SwitchMap? I know if you ever go to Stack Overflow and look at the RxJS solutions, the answer always is SwitchMap, right? That's always the right answer for any problem anyone's having. So we're going to talk about MergeMap, ConcatMap, and SwitchMap. Oh my, which one should we be using when? Is SwitchMap the best practice? The answer is, it depends, which, you know, everyone hates that answer, right? It depends. All right, so we're going to stick with our same scenario here. This time we want to get the to-dos for that user. And we still need that user ID as a parameter on our HTTP GET, so we still need to have some kind of mapping there. So I actually used track and track as my metaphor here. Think of ConcatMap like a relay. With a relay race, they have to retain their order. That second person cannot start running until that first person has completed. And the ConcatMap works the same way. It waits for the prior one to complete, and then it repeats the mapping operation. It retains that order. So in this example that we've been talking through, I come in the morning, I'm kind of tired, it's been a long ng-conf, and I want to check on my junior's progress. So I pick the second one. Oh, no, I meant the third one. Oh, no, I meant the first one. So that's our scenario. I've rapidly picked the second user, the third user, and then the first user from my list of users here. What's going to happen on a ConcatMap? It's going to go to get that second data and wait till it comes back. Then it's going to start getting the data for the third one, and I really wanted the data for the first one, but now it's going to wait for that third one and then finally get the first one and get that response back. So ConcatMap is not the best practice for that particular scenario, but it is best practice for any other scenario when emissions need to be processed sequentially, one at a time, and order matters. So insert, update, and delete are prime examples. If I do an insert, immediately update it, and then delete it, I want those processed in order, one at a time. MergeMap you can think of like the 800 meter. Everyone starts out all at the same time, and they don't all finish in the order they started. So emitted values are processed right away. They all start all together. Then it performs the mapping, which in this case is the running, and the order is not maintained. So here again is our same scenario. When I pick 2, I pick 3, I pick 1. 3 comes back first because that person happened to have fewer tasks. Then 1 comes back. Then 2 comes back. So I'm looking at the screen and I picked the first user and the data I have is for the second user. So that's not a good choice either in this particular case. Does that mean MergeMap is not useful? That's not the case. MergeMap is very useful. When is it best practice to use MergeMap? When we want all the emissions to go all at the same time, or relatively at the same time. We want it to be more performant when order doesn't matter. So retrieving related data when the criteria for that doesn't change like it did in our user pick scenario. We'll see an example of this coming up. All right, the last one is SwitchMap. That one is like changing your mind. I'm going to start this runner as my starting leg. No, I'm going to change my mind. No, I'm going to change my mind again. Only one of the runners end up actually running. So it stops the process and switches over to the next runner. So again, walking through our scenario, I pick the first one. It cancels then the getting of that second user, and it gets the third user, and then when I pick the first user, it cancels the third one, gets the first one, and I only end up getting the first ones back. Did that all make sense? Yes, thank you. Okay, so we use SwitchMap when only the latest emission matters. So in this kind of case where a user could be making multiple choices, and also for type ahead. All right, so let's do 3 more. ForkJoin, CombineLatest, and zip. ForkJoin, you can think of that as, well, first of all, it's a creation function, not a pipeable operator. That means we call it directly, not within a pipeline. And what it does is it waits for all of the observables to emit and complete. And then it emits the last value from each. So our $A shoots off 1, 2, 3, 4. The ForkJoin doesn't emit anything because B$ hasn't completed yet. So then B$ shoots off A, B, and C, and then it completes, then it takes the last values from each, so 4 and C, and that's what it returns. Now at first glance, that doesn't look all that useful. When would be a best practice to use that? But when we think about how HTTP works, it's always one and done. So it's always emitting and completing. So it makes great sense to use a ForkJoin in the case of using HTTP requests. So here's an example. I'm getting my user, and then I am finding, I'm getting all the users with their to-dos. So in this case, I'm getting all of the users, and I'm matching up all of their to-dos, and I'm going to return this user data array. So this guy here. So I'm going to get an array of those, and I'm using a ForkJoin here to take every individual user and then get all of their to-dos. And it's going to one and done each one, wait for all of them to finish before it then emits my final array. Hopefully that made sense. All right. So it's great for getting related data for each item in the array because they were mapping through each of the users and getting their to-dos. CombineLatest is also a creation function, though CombineLatest now also has a pipeable operator with CombineLatest with. CombineLatest waits for all observables to emit at least one time. And we need to watch out for subjects when we combine latest with the subject, because the subject won't initially emit. Then when any observable emits, it combines the latest value from each. So the 1, 2, 3, 4 are all going to emit, but the CombineLatest won't do anything because the B$ hasn't emitted yet. As soon as the A is emitted, then it's going to take the latest value from each, so the 4 in the A. When the B is emitted, it takes the 4 in the B. When the C is emitted, the 4 in the C. And again, it might not seem real useful until you think about HTTP. The other place that it's really useful is when you want to combine all of your streams to have one async pipe on your template. So what this code is doing is it's mapping 2 streams, and this could be, 6, and mapping them into a object so that you can more easily access them on your template. So it's great for combining any amounts of data. The last one is a zip, which is also a creation function. And here it waits until each observable emits, then emits the value from each observable as a set, and then it repeats. And it's hard to actually describe how this works, even though it's somewhat easy to picture it. Here it's going to emit 1, 2, 3, 4, and then it's going to emit A and match it up with the 1, B and match it up with the 2, C and match it up with the 4, or 3 rather, and then it's going to just throw the 4 away because it doesn't have anything to match it with. Here's an example of a zip. We're zipping the user with their profile. So it's good for combining sets of one-to-one data. It's also great for handling key and value pairs. Previously, I did a talk at ng-conf where I covered the group by, and I used zip to match up the key and value pairs of the group by. In the last few minutes then, we're going to talk about some basic best practices. I'm assuming in this group that most of you probably already know these, but I know a lot of you do have juniors that you're going to be going back to talk with, and these are some things that you could share with them to make sure that they are following those best practices. So the first is don't forget to unsubscribe. So the general rule of thumb, or I guess finger on the image here, is if you subscribe, then you should be unsubscribing. And so that's a really good kind of junior level general rule to follow. But a better solution, a better best practice is to not have to subscribe at all and instead use an async pipe. If you use an async pipe, then it automatically subscribes, it automatically unsubscribes, and it re-renders every time another item is emitted. So your screen will, your UI will update. Next, don't forget error handling. I know it's easy to just get some code in there that's running and works and kind of forget about handling the errors. So here is an example of some error handling, just catch error. And this .handle error then looks like that. And here we've got an observable of never that we're returning. It emits no items and never completes. We do that because if we do something, we try to return something else like an observable of string, you will have difficulty here because you'll end up with an odd return value on your user's dollar. So if you've ever seen anything weird when you added your error handling, that suddenly your user's dollar changed its type from a simple user array, observable of user array to observable of user array and some other weird thing, it might be from the return value on your error handling. Does that make sense? Hopefully, thank you. All right, the next one. Don't nest subscriptions. And yes. So this happens most often in procedural code. So I've got a procedural code example here. So here is my HTTP GET to get the user. In this case, I'm actually passing in a user name, and then it's taking that name to get the user ID, and then it's taking the user ID to get their list of to-dos, and it's subscribing here, and it's subscribing here. And one of the biggest problems with this is you've just created a whole bunch of subscribes, one for every user that this is going to process through, and you're not going to be able to get a reference to that subscription in order to be able to shut it down, to unsubscribe. So what do you do instead? Well, the best answer is to go reactive. Thank you. Let's try it one more time. Go reactive. There we are. So that's the best answer, but sometimes you still have procedural code that you have to deal with. So the second best, let's not doing that. So the second best answer is to use a higher order mapping operator on the inside. So what this does is you still have that outer HTTP request with the subscribe, but by using a higher order mapping operator for this inner one, it will automatically subscribe and unsubscribe its internal observables for you so that you don't have to worry about having these not unsubscribed subscriptions. Okay? All right. One of the complicated terms that I ran into when I was first learning observables, I read through the documentation, and just in reading paragraphs, it kept talking about an outer observable and an inner observable. And in just reading paragraphs, I was like, what the heck is that? When you look at it on a picture like this, it makes great sense that this one is the inner observable and that one is the outer observable. So I just thought I would throw out those words to make, since it so clearly was represented in this screenshot. Thank you. All right, last one, best practice number 1. Have fun.